So we are going to create a counter. How many times has somebody come to our web page using cookies? And so we're going to do HP listen and serve, and we're going to do :8080 and default serve mux, and we're going to do http.handlefunc, and we'll have route, and we'll do foo, and so we'll do func foo, and it'll take a response writer, and it'll take a pointer to a request. And now we want to create a cookie. And that cookie is going to be hp.cookie, which is a struct. So we're using a composite literal here, which is the type, curly braces, and then the values. And we're going to have name. And so we'll call it, I don't know, wackadoodle, whatever. And we'll have a value. And we'll set that to 0. And we'll have a, value has to be a string. And we'll have a path. And we'll set that to that /. And that just means that anything at our domain and on down the line is going to fire this cookie. And so we have that cookie. And now we want to be able to check if there's a cookie when a request comes in. So how are we going to do that? Check to see if there is a cookie. We also want to be able to set the cookie before we leave. And then we want to write the counter. So if, just thinking here, I haven't done this in a while. So we want the, we need the io.response writer. Well, we could create a web page kind of into this templates page, and we could do index.go.html, and so we could have this, and then we could pass some data in. And so here we could do if there's data, end, and value of cookie. We'll just do this. Boom. See what that does. There we go. And we now need in main to have a init. So var TPL is a pointer to from package template type template, and init. And TPL is equal to template.must and template.parseGlob. And it's going to parse templates /star.go.html. And then we'll have template execute down here. tpl.execute template to our response index.go.html. And we're going to pass in c.value. And then checking if there's a cookie, if r.cookie, right? Like if r.cookie, cookie's the name, and the name is wackadoodle. Like, what are we checking? Like, how do we check to see if this exists? So let's go look at the documentation and see if we can figure it out. HTTP, we have a name. And so r.cookie, the request comes with the cookie. So let's look at the request. So here's the request. Here's cookie. We give it the name, right? So request cookie name returns a pointer to a cookie and an error. Okay, so request cookie, our cookie, right? That's what we're calling right there. We give it the name, returns a pointer to a cookie and error. So we're going to, here we're creating a cookie. Here we're asking for a cookie. So we should ask for our cookie first maybe. And if there's no cookie, we want to then create it. So if error is not equal to nil, would we want to create our cookie here? Or at least assign values to it, right? So maybe we need up here, we need var c is equal to, var c is a pointer to an HTTP.cookie. So we have a variable c which is of type pointer to an HTTP cookie. And here we're saying give me the cookie, and we're going to assign that to c. And we could use colon equals because we've never used error before. So it's not redeclaring C. Pretty sure that's right, like 90% certainty on that. And then if the error is not nil, so if there's no cookie on the request, right, there's an error, we didn't get a cookie, we're going to do this bit where we kind of create a cookie and assign it to C. Okay. Is that good? And then this is the first visit to the page. So C dot value plus plus. No. C dot value is a string. So S colon equal C dot value. Or we could do an int. We could convert. And I always like to kind of like Golang playground. Like if I have x colon equal 0 and x f %t %t x capital T string, right? And then can I do this? Just do conversion. Can't convert x type string to type int. You know what I need to do? There is godoc.org A2I, and that is in strings. Strings package, and there's ASCII to int. Is that not in here? Index, map, split, to lower, trim, builder, reader, replacer, Golang A2I. String convert. So that's package strconv. strconv. And here is string convert ASCII to int. So that's what I need. So I'm going to do y colon equal string convert ASCII to int x. And this is y. And this is y. Multiple value A2I and single value context. So that means that it's giving me an int and an error, and I need to check that. So I need a int and an error, and I'll just throw the error away. and it'll work. Whoop, perfect. All right, so I need here to do, I am at a string, I need to go to an int and an arr, and I need string convert a to I, and I need cookie.value, right? And if arr is not equal to nil, then HTTP dot, what's the response? Bad request, server something. Here's HTTP. I'm just skimming through this. I'm gonna look for code, see what kind of code. We have redirect, we have status text, redirect, arr. I think I'm going with arr. HTTP arr, response writer, arr, and code. So I'm going to do HTTP arr, response writer, bad request, and error code is 400. HTTP bad request 400, and then return. So we're out of that function at that point, right? We leave foo. So we come in, we create a cookie, right? And we check to see if there is a cookie. If there is, we assign it to C, which is that value up there. And if there's an error, then we actually create a cookie and assign it to C. And then we're going to take the value and turn it into an int. And then we're going to increment that. So we just added 1 to it. And now we're going to go c.value, and we're going to set that equal to string convert. We did ASCII to int. Now we're going to do int to ASCII. Isn't it int to ASCII? I to A. There we go. And it's I. And if we wanted to just sort of truncate all that a little bit shorter, we might try putting I++ right here. But that might be an entire statement and not an expression. I think I remember reading somewhere I++ is a statement, not an expression. So if we wanted to, we could go look in Golang spec and also effective Go. And we can look for plus plus. Operators and punctuation, right? That's operator form statements, not expressions. They fall outside the operator hierarchy, right? So we just want statements on a single line. So I think this would probably blow up. But we'll try it and see what happens. See, I'm already getting an error, right? So we're not going to go any farther than that. So that's it, and then we're passing that value in. That's pretty good, right? So is there some way we could abstract this a little bit? Because this stuff, if we were to have multiple pages, this is going to run on every page, right? Isn't it? We're going to check. We're going to, want to have a cookie, check to see if we got a cookie. If we didn't get a cookie, we're going to create one, then we're going to increment it, and then we need to set it, brother and sister, we need a set cookie, response writer, and what else is in the set cookie? Come on, give me my code completion. Response writer and the cookie, set cookie. Unresolved reference C. Set cookie response writer and a pointer to a cookie. Set cookie adds a set cookie header to provide response writer headers. Provide cookie must have a valid name. Invalid cookies may be silently dropped. Well, there's the cookie, yo. Oh, because I have a dot, not a. There we go. Set cookie and then this. So can we abstract all this? Yeah, and do we want to include set cookie in it or leave set cookie here? Kind of seems like I want to have set cookie in foo for some reason. I don't have a good reason for that impulse within myself. But let's take this first. So to create a function, I don't know, counter, cookie counter. What's that going to take in? Pointer to an HTTP cookie, right? What's it going to return? Oh, it takes in the request. You're so right. And what's it return? Doesn't need to return anything. We have the address.
Well, yeah. If you do the HTTP set cookie in that function, will it just tack on the cookie to the request, and then so when you go to your execute your template, the request already has it?
No, it needs to be the response writer it's given to. So we could pass in the response writer. That's where I feel like, you know, if we pass in the request, we could return a cookie. All right, here's the request. Give me back my cookie. And then C is equal to so yeah, we'd have to have the response writer in here to add it on to that response writer. And then if we pass this in, we'd need to start thinking about addresses, because otherwise it's going to make a copy of it when it comes in, passed by value. Right? So that's kind of like I think my instinct was returning a cookie. And this is returning now we returned, I think should we return the address here, or should we take the address just when we need it? Is there any reason to have oh, and look at our error here. So it's almost like we need to return an error. And then up here we need do we want so we've got the request coming in. Do we want it to be a pointer to a cookie at this point? you should limit taking addresses until they're needed. Bill Kennedy has an amazing perspective on this. I can't totally remember it right now. So we get the request. Like, should we just do this? Like, because where do we need? Oh, because our cookie returns a pointer to a cookie, so we do want a pointer to a cookie. All right, just thinking that through, right? And then we're going to return C and nil. So there's our cookie counter. And we say, here's our request. We get back the cookie. We set the cookie. And then we send in the value. So now we could have a couple of pages. This is a long video. All right, let's run it, see what happens. Does it look good? Well, we'll find out, right? All right, I'm at home. And it was foo bar. I'm at bar. Pretty good, right? How many people like it?
Let us go to what is it? I. It returns an integer, right?
Yeah, ASCII to int returns an integer.
So if someone had a bot and they just like refresh that page, they got like say an overflow, like they got it above like was it 4 billion for an integer, or the maximum integer, 4 billion. Would it crash our server?
So you're asking what happens when int, which is the same size as a uint, which is an unsigned int, and it's going to be either 32 or 64 bits, and I'm on a 64-bit machine, so it's this number. You are asking what happens when that number, when we get above that number for an int. Let's find out. What happened? The cookie was there, so it never ran here, right? So I need to delete that cookie. Why is it a bad request? Why are we getting this? We're getting an error back. We're not doing anything with that error. Let's print that error out. Let's go back to 0. Another way we could check that, just like to isolate it. Overflows int. Not sure. Oh, I'm not sure why, because that's like 1 under, right?
Oh, is it? But that's a regular int, so it shouldn't be an unsigned int?
Well, it said it's unsigned. uint 64, right? An int is the same size as a uint. A uint is either 32 or 64 bits. So uint 64, because that's my machine, should be this 0 to that. We could try 3. Back it off a bunch. Yeah, so at some point we went too big.
But a regular integer should be signed to, right? So doesn't it go backwards? Or for negative numbers? Is that something?
This is signed. It's got a negative to a positive.
Yeah.
This is unsigned. It's just positive. There's no negative. There's no sign. Does that make sense?
Yeah, that makes sense. Well, an integer and a uint are two different things, right? They're the same size, but two different.
No, a uint is an alias. Int is an alias for a uint. It's only if you specify int 64, which is different than int, or int 8 that you get assigned. Otherwise, int is unsigned.
So if you had like 1, if you said it like if you just called it int and say had 1 and -3, it wouldn't work. It would give you like a weird. Would I go to the very end? Like you know how
You mean this?
like subtraction would work.
That?
Yeah.
Don't know. Let's find out. I mean, this is how you kind of like start to try to understand stuff, right? You just keep asking questions and I mean, that's my understanding, which isn't jiving right now, what I explained, right?
Yeah.
Because that's the way it reads to me, is that an int is the same as a uint,
Yeah.
and a uint's either 32 or 64 bits. Right? And it's either going to be uint 32 or 64, but maybe it switched down to here. You know, maybe this number would work. Where did we have that before? It's fine with that number. What happens if we go to 8? It's one too many, man. So it looks like, for whatever reason, it's going to signed. So maybe it figures out which to do. Maybe uint, like if we specified uint here, okay, and now it's unsigned. So now that's going to run, and let's see if this runs. That runs. Go one more. No. Right? And do this. Get a negative, not going to run, I bet you. So int is same size, not same sign, I guess. So we got int and uint 32 or 64. Right? To me, it would have been a little bit clearer if right here they just said uint either 32 or 64 bits, int either 32 or 64 bits. Because uint drives to this, int drives to this. That's new information for me. I'd never explored that. Great, Jeff. Let's end this video. It's super long.